Next question here. The next question here is like this. There is this area bounded between the curve and two lines. Now these two lines, they are very funny. One line is parallel to the y-axis, another line is parallel to the x-axis. So it becomes a 90 degrees, then with the curve there, right? So this area bounded by the curve and the perpendicular lines, they are x equals to 2 and y equals to 5/3. Okay, these two are perpendicular lines here. One is x equals to 2, another is y equals to 5/3. So this area bounded by them is rotated in two different ways. This bounded area, in the first case, is rotated about the x-axis, and we have to find the answer. Then part B, the same area is rotated about the y-axis, and we have to find the area. Wow, how to do this? How to do this? Okay, so I have enlarged this part here. So the part that we need to rotate is shaded in gray color. I shaded the part that we want to rotate in gray color. So when this part is rotated about the x-axis, actually it is from the curve until the x-axis here with all the blue lines there, and you have to rotate the whole part about the x-axis. Okay, so is when you rotate, not only the gray part is rotated, but the part that is not gray, the yellow part here is also rotated, about the x-axis. Not only the gray part is rotated, the yellow part is also rotated about the x-axis. But we only want the gray part, we don't want the yellow part. So what should we do? What should we do? This whole thing, the blue part, okay,
The blue part minus the yellow.
Correct, the blue part minus the yellow one. Very good. Now, the yellow part is a rectangle. When you rotate them, what will you get? You are actually getting a cylinder. You are actually getting a cylinder. Okay, now you are getting a cylinder. So the blue part, when you rotate, is the usual one lah. Like, I don't know, it's like a loudspeaker like that. You know the hailer, they use the loudspeaker and then, they talk that part like that. So that part is the one come from the integration, right? The blue line. Then the yellow line, the yellow part, when you rotate, it becomes a cylinder. So actually what I want to find is this one here. The volume of revolution, the required one, is the blue part, which is pi y square dx, minus the volume of cylinder. Is this okay or not? Any question before I continue?
No, teacher.
No. No, then I need to find out these coordinates here, the B and the A. Why I need to find the B and A? When I find the B and A, I know the upper limit and lower limit where I should integrate. When I find the A and B, I also know what is the size of the yellow part behind. So you cannot straight away find the volume unless you find out this point A and the point B. So how to find the point A and the point B? Now it comes from this part here. The curve y equals to x/10. The curve is this blue line here. y equals to x over 10. Now I know that the line is, one of the line is y equals to 5 over 3. Okay, this line is y equals to 5 over 3, the green line. So another line here, the blue line here is, the long blue line here is x equals to 2. It is given here. It's given in the question here. The green line is x equals to 2. The blue line, sorry, the green line is y equals to 5 over 3. The blue line is x equals to 2. So I use this x equals to 2. I substitute inside the curve 1 over 10. And I found the y equals to 5. So this point is actually B. 2, 5 is actually B. In order to find A, I substitute this y equals to 5 over 3 is given in the question, y equals to 5 over 3. I substitute inside the curve, right, 5 over 3 equal to 10 over x. And I found out the x is 6. The x is 6. This is finding out the points A and B. Find out the points A and B. So after finding out the point A and B, now I want to find the blue color, like Li Ying said just now, the blue color. The blue color is from the integration by y squared dx. Okay, the blue color is from the integration by y squared dx. This one. The blue color is this one. Integrate by y squared dx. But from where to where? So you see the blue color, the lower limit is 2. The upper limit here is 6. From the coordinates also I can find. Right? X equals to 2, x equals to 6. Okay. Then how about the cylinder? Which this cylinder is the yellow color one. So before I proceed with the yellow color, you have any problem with the limit from 6 to 2? The blue color one, from 6 to 2, integrate from 2 to 6 by y squared dx. Any problem with the blue color?
No, teacher.
No. Then I start with the yellow color now. The yellow color will actually, when it's rotated, it will form a cylinder. It will form a cylinder here. It will form a cylinder here. The yellow color will form a cylinder. Okay, it will form a cylinder. So what is the height of the cylinder? The height of the cylinder here. From 2 to 6. How long is this? From 2 to 6. The height of the cylinder is 4. 6 minus 2 is 4. Then how much is the radius of the cylinder? How much is the radius of the cylinder here? The radius of the cylinder is, until the green line, is this one. 5 over 3 is 5 over 3. This one. This line, green line, is 5 over 3. Okay, right. So finally, for the blue part, I have integrate by from 2 to 6 y squared dx. The y is 10 over x. So y squared is 10 over x squared. Then minus the volume of the cylinder. Now this yellow part here, I only show the area. In this diagram, I show the volume. There are two. When you rotate, there's one at the top, one at the bottom. So this one is the cylinder. And what are the dimensions of the cylinder? Okay, the cylinder, the radius is 5 over 3. The height is 4. This height is 4. This height is 4. Right, the height of the cylinder. The radius of the cylinder is 5 over 3. 5 over 3. Any question?
No, teacher.
No, it's very clear. Drawn there very clear. Okay, so now we proceed.